All right, welcome to the Explainer. So today, we're going to dive into one of the most profound questions anyone has ever asked, and a pretty radical scientific proposal for how to answer it.
I mean, this quote from Richard Feynman, it's really the heart and soul of science, right? It's this strict, non-negotiable rule that keeps us grounded in what's real. At the end of the day, data wins. Well, believe it or not, a paper by a researcher named Dr. Gary Schwartz proposes a way to do just that. He wants to apply the most rigorous tool we have in medicine to this absolutely extraordinary claim. Okay, let's get into it. You've probably heard this before. The great astronomer Carl Sagan had this famous saying, extraordinary claims require extraordinary evidence. And, the claim we're looking at today is, well, it's about as extraordinary as they come.
See, this paper isn't just, throwing the question out there. It's proposing a concrete, repeatable experiment designed to get a real answer, either a yes or a no. The whole point is to try and move this topic out of the world of belief and into the world of hard empirical data.
So, to gather that kind of extraordinary evidence, where do you even start? Well, the proposal turns to the absolute gold standard of medical research, the randomized controlled trial, or the RCT. It's really the most powerful tool we've got for finding a true signal in a world full of noise. You see, we use these things, these RCTs, to prove if a new drug actually works, because they're just meticulously designed to get rid of human bias, wishful thinking, all that stuff. So the big question is, how on earth could you apply that same logic to something that's, well, unseen and non-physical? This is where it gets really clever. Take a look at how the core principles translate. Instead of a pill, the treatment here is the hypothesized presence of a spirit. And check out that last row. The entire system is designed to be fully automated. No physical experimenters are even in the room, which is a huge deal for eliminating any possible human influence on the results. Okay, so if you're going to build an experiment for a spirit, what's the task? What do you ask it to do? And more importantly, how could you possibly measure if they've actually done it? Let's see how the paper tackles this. Okay, first things first, let's get the terminology straight. The paper uses this very neutral scientific term, hypothetical spirit participants, or HSPs for short. And the experiment invites these HSPs to do a very specific and actually very modern task. It's basically a modified version of one of those I'm not a robot CAPTCHA tests you see all over the internet. It's a simple yes or no question, but answering it correctly requires a real cognitive understanding of what you're looking at. And yeah, this gives you a perfect idea of the challenge. Just like when you're online, the HSP would need to correctly identify which of these squares has a vehicle in it. Simple enough. But what are they supposed to interact with to give their answer? The answer is surprisingly simple and honestly pretty elegant. It's a plasma globe. The whole hypothesis is that an HSP, a form of consciousness or energy, could maybe, just maybe, subtly influence those delicate streams of plasma. A change that would be totally invisible to our eyes, but that a sensitive camera recording hundreds of frames might be able to pick up. All right, so this is the really critical part, right? How do you actually see that tiny, subtle influence? The whole system runs inside a completely dark shielded box, and it's constantly collecting video, looking for any meaningful change between when a question is asked and the time given for a response. If you just look at one frame of the plasma, it's just chaos, right? A random dance of light. Even if you average hundreds of pictures together, like you see on the right, it's still hard to spot a clear pattern. But the real magic happens when you use software to digitally subtract the before image from the after one. So what the software does is it takes the after picture, the one recorded during the response time, and it literally subtracts the before picture from it. All this does is reveal what, if anything, has changed. It filters out all the constant background noise of the globe itself, leaving behind only the potential signal. The paper calls this the delta-delta image. And this is what the paper presents as its preliminary results. On the far left, that's the pattern created when a living person interacts with the system. On the far right, that's the control, when nobody was invited. And there, in the middle, is the average result from the HSP sessions. The paper argues it shows a clear structure, one that looks different from the random noise of the control, and shares some similarities with the living person's interaction. This is the extraordinary evidence they're talking about. But, and this is so important, the paper makes it clear this isn't the final word, not even close. In science, one lab finding something interesting is just step one. For it to mean anything, it has to be repeatable by other people. So what it's really doing is calling on other labs, totally independent labs all over the world, to build the exact same setup and run the exact same automated experiment. That's the only way to see if the results can be replicated. It is the absolute cornerstone of good science. And the design itself is just packed with safeguards to make sure the results are legit. The schedules are randomized and hidden from everyone. The data is collected by a computer and digitally fingerprinted, so you can tell if it's been messed with. And really importantly, the whole setup is pretty cheap, under $3,000, which makes it way easier for other labs to actually build one and try to replicate the findings.
So at the end of the day, whether this experiment works or it fails completely, that's almost beside the point. Applying our most rigorous, skeptical methods to our deepest, most profound questions, that's what science is all about. It's about being brave enough to test the extraordinary. And that's our explainer for today.